We're not done with the hypothalamus and pituitary yet. This video is about the hypothalamic pituitary organ axes. These all refer to the anterior pituitary. And by an axis, it means a pathway, basically, with multiple steps. You've already actually seen this. Let's draw out the generic signaling from the hypothalamus to the anterior pituitary to organs, other endocrine organs, which then release a hormone. So this is what should look not like anything super new. Hypothalamus releases a releasing hormone. It also could release inhibiting hormones. We're going to focus on the stimulation, so releasing hormones. That releasing hormone is going to target the anterior pituitary. This is that local portal system. The anterior pituitary is going to release a hormone into circulation. So a true, hormone. This is a hormone too because it's going into the bloodstream. It's not a paracrine because it's going into the bloodstream. A paracrine relies on diffusion to contact the local tissues right nearby. This is being actually shuttled in a tube. This is going to go to circulation to target some endocrine organ. The endocrine organ is going to release hormone that's going to affect other target organs potentially. This organ also might do something. So we'll see some of that, like the ovaries and testes. So this is the anatomy that goes with that. Should look familiar. Releasing hormone here. This calls it hormone 1, hormone 2. I don't really care if this is hormone 1, 2, and 3, or you call this hormone 1, hormone 2. I don't care. You need to know what hormones are where, right? So this is the same idea here. So let's look at these pathways. Let's name the hormones and organs in these pathways. Let's do that here. So this is the pathways I'd like you to know once we put the information in. So one is going to be called, I like to name them, so HPT. That name has some meaning. So that's going to be the hypothalamus pituitary thyroid axis. So we're going to have TRH, thyrotropin releasing hormone, released from the hypothalamus, targets the release of thyroid stimulating hormone from the anterior pituitary. Here we're going to name the endocrine gland that is targeted by TSH, the thyroid hormone. An endocrine organ is going to release T3 and T4 are the names of the thyroid hormones. Those are going to affect metabolism. We'll get into that in a later video. A bit more of this. These are just the pathways. We'll actually go into the pathways in more detail, of course. Super cool. This one is HPA, so adrenal gland. This is part of the stress response. So you'll see tons out there. If you Google HPA, you'll probably get a lot more than Googling these other terms. HPA function is implicated in all kinds of processes, all kinds of emotional states, anxiety, depression, all kinds of things. So HPA axis is going to target, why don't we just write that in first, the adrenal gland, hypothalamic pituitary adrenal gland. And actually I'm going to remind you up here, these are all anterior pituitary as listed right here. So HPA axis is going to start with corticotropin releasing hormone, which is going to trigger corticotropin release, adrenocorticotropin hormone, corticotropin releasing hormone. The names make some sense. I'm fine with you using abbreviations, but knowing the names, at least like now as you're studying, using the names, the full names, helps it make sense. Releasing hormones are all from the hypothalamus. Stimulating hormones or corticotropins are from the pituitary typically, and then it's kind of a mixed bag after that. The adrenal gland is going to release cortisol. Stress hormone. We'll talk more about it, but you've probably heard of it related to the stress response. You also have heard of, well, I'll come back to that. Let's keep going. We've got growth hormone, releasing hormone. This I will talk less about. Going to cause, of course, the release of growth hormone, which actually, I think I had this in a different video. It actually triggers the liver first. I'm not going to actually go into this. I'm going to say skeletal system, musculoskeletal. We're not going to do this one in more detail. It does actually have this same pathway where the liver triggers these target cells, which are these. There's growth factors in between here. We're not going to do this one further, but it does fit. Growth hormone releasing hormone triggers growth hormone to target the liver and then target cells. Same pathway fits. There is also growth hormone inhibiting hormone that exists, and that's actually somatostatin. So these are basically the ones that we are going to care about the most so far. Then we've got GnRH. This one we're also going to care about because it triggers the release of gonadotropins. I'm going to write those gonadotropins out by their specific names here: luteinizing hormone and follicle stimulating hormone. Those are both gonadotropins. So again, tropic hormones that are going to target the gonads, ovaries and testes. The gonads are going to release sex steroids, testosterone, estradiol, progesterone. This one we'll come back to a little bit this week, and then with reproduction next week. Again, you can't say repetition doesn't help. It does. I've got one more. What is it? I think I was just going to add in there. Let me make sure I'm not forgetting something else. CRH, TRH. Okay, I think the last one I have is one you also don't need to know. It's dopamine. Pretty cool. You know, dopamine is actually going to inhibit prolactin. There are also prolactin releasing hormones, put or, so there's inhibiting or releasing hormones. Prolactin is actually going to target a non-endocrine organ, the breast tissue. So that's one where it kind of skips that same pathway. So the ones that are starred here are the three that we're going to focus the most on and that fit best with that pathway. You'll see here is also negative feedback. I mentioned before as well. So T3 will turn off TRH and TSH. Cortisol will turn off, inhibit CRH and ACTH, etc. That will be very important. This picture is a summary. I don't actually love it. but it has basically everything I just showed you with some of the anatomy, some of the specific targets. So you can use it to study. Do notice it also has these posterior pituitary hormones over here, oxytocin and ADH. It's got the adrenal medulla innervation over here. So this is everything the hypothalamus does. Not really everything, but a lot.